Okay, we ran into, people have a little bit of trouble with this, so let's be sure we understand this in terms of the distributive law. Now, typically, just to see what's going on, I would do something like this. You got the 6 and the minus 10, right? And you know that there's a common factor, which is 2. So we could write this as 2 times 3x to the 8th, y to the 15th, minus 5x to the 17th, y to the 11th. Okay? So we've done a little bit of factoring, but there's a lot more to do. But there's nothing more we can do with these numbers because 3 and 5 don't have common factors. Now, some of you are using prime factorization. You're going to write your 6, and you're going to say, okay, that comes down to 3 times 2. You write your 10, and okay, that comes down to 5 times. That's good. Because you got big numbers here, you pretty much almost need to do this, okay? Okay, now down here, so this one's pretty simple. The numbers are not too difficult. So why do I know that this works? Because this means 2 times this minus 2 times this, distributive law, right? And it's clear that 2 times this gives you this, and 2 times this gives you this. So your test is always use the distributive law and see if it takes you back to where you started. So I could do this, okay? Let's get adventure. So I could do 2xy times a couple of things. I know this is going to be minus, okay? What would I multiply 2xy by in order to get this? Well, I'd have to have a 3 because I need 6. 2 times 3 gives me 6. Now, x times what gives me x to the 8th? Well, x times x to the 7th gives me x to the 8th. So if I have x to the 7th here, I'm going to get my x to the 8th when I multiply through. Okay? And also, I need a y to the 14th. Okay, over here, multiplying by 2xy. Well, the 2 times negative 5 is going to give me 10. What would I multiply x by to get x to the 17th? It has to be x to the 16th. What would I multiply y by to get y to the 11th? It would have to be y to the 10th. If I multiply all this out, I get back to my original expression. Now, these intermediate steps, you would not ordinarily do it, but I'm building this up a little bit in a way that hopefully is going to make more sense. Okay, I could do 2x to the 7th, y to the 7th. I wouldn't really do this, but again, we're illustrating at every step how the distributive law takes you a little further. Okay, well, I'm going to need the 3 for obvious reasons. I don't need any more x's. I've got x to the 7th. I don't need any more x's. I've got y to the 7th times what gives me y to the 15th. Okay, well, I'm going to need a y to the 8th. Now check it out. Multiply this by this. I get 6 here. Matches the 6. I get, if I did this, I'd still need an x. I was looking up here. Okay, so by checking this, I find the mistake I pretended to make. Okay, yeah, I know. I really made it. Okay, so x to the 7 times x gives me x to the 8th, right? Y to the 7th times y to the 8th gives me y to the 15th, and it works. Okay, over here, I would need the 5, obviously. Now, x to the 7th times what gives me x to the 17th, it would have to be x to the 10th. Y to the 7th times what would give me y to the 11th? Well, it would be y to the 4th. Okay. Now, I'm not done, but I'm making progress. I can check the distributive law here and make sure that I get back to here. If you keep at this a little while, well, you can see I've got an x in common here and here. Okay. So I didn't need to stop at x to the 7th. I could say this is 2x to the 8th. So now I have the 3 and the minus 5. Okay. To get my x to the 17th here, x to the 8th times x to the 9th is x to the 17th. So that's 5x to the 9th. Now what about my y's? Well, I've got a y to the 8th and a y to the 4th here. These have a y to the 4th in common, so I could factor out a y to the 17th, y to the 11th. Okay, now if I multiply this by what to get y to the 15th, well, I'm going to need a y to the 4th, because y to the 11th times y to the 4th gives me my y to the 15th. I've got the x to the 8th, I don't need any more x's. And 2 times 3 is 6. Over here, okay, I've got my 5x to the 9th, because x to the 8th times x to the 9th is x to the 17th. Y to the 11th times what gives me y to the 11th? Well, it turns out I don't need y. Okay? Now, I don't need all these intermediate steps that they do. I wanted to make them just to illustrate the distributive law at every step. And sometimes you won't factor everything out and you look at what's in here and say, well, I still got an x in common. I look here, I still got a bunch of y's in common here. Okay? So what we look at to do this directly is we say, well, I've got x to the 8th and x to the 17th. I can factor out x to the 8th. Okay, because I got the x to the 8th out here, there's a power of x that I can use with this term that'll give me the x to the 17th. And then my y's, I've got a y to the 11th. These are chocolate. Okay, got a y to the 11th there. So I can factor out the x to the 8th and the y to the 11th. Because I've got a bigger power of y here. I've got a 15th power, I've got an 11th power. With x, I've got a 17th power and I've got the 8th power. I look for the smallest power that's a factor of everything. The smallest power of x between these is the 8th power. That's what I'm going to factor out. Smallest power of y between the 15th and the 11th, obviously is the 11th. So I factor out y to the 11th. 6 and 10 have a common factor of 2. So I just skip directly to this. I write out if I'm not doing all the intermediate steps, and I don't need to do them at all, I have this, and I have this. If I know what my greatest common factor is, then I just have to ask myself, what has to go here so I get this? What has to go here? Well, I've got to have a 3. And I don't need any x's because I've got them all. Y to the 11th to get y to the 17th, the 15th gives me, I need y to the 4th. So when I multiply this by this, I get this. I don't need the stuff in the middle. Okay. And over here, I get 5. 2 times 5 gives me 10. X to the 8th times what gives me x to the 17th? It has to be x to the 9th. And I've already got the y to the 11th, so there I have what I had before. But I just got it by identifying what my common factor is. 2 here. Might as well circle that. Who's my common factor? X to the 8th is a common factor. Y to the 11th is a common factor. Okay? That's the problem. Okay, now factoring by grouping, again, something that almost never occurs in the wild. Okay? In the real world, you very seldom find anything that'll factor, period. And particularly, you don't find many things that'll factor by grouping. Okay? But if you have a cubic polynomial like this, a third degree polynomial, if it factors, very often you see that it will factor by grouping. look at this, we got 4x cubed plus 7x squared minus 16x minus 35. You could factor an x out of these two. There's not much of anything you could factor out of these two, right? So what you do is you try this. You say, well, let's see. Let's group the x cubed with the x term. And the 7x squared and the minus 35. Okay? You just rearrange it because you have the commutative law of addition and the associative law, and they put them together, and you know perfectly well you can write these in any order you want to. Now, normally your standard order is in decreasing powers of x. But here, we rearrange out a little bit and see what happens. And you say, well, we can factor a 4 out of here. We get x squared minus 4. We can factor a 7 out of this. Now, if this was x squared minus 5 and this was x squared minus 5, we could then use the distributive law and say we factor a 4 here, we factor the 4x. Okay. If these are both x squared minus 5s, we could then say we have 4x plus 7 times x squared minus 5. So this almost worked, but it didn't quite work. Okay. But it's something you can always try. As I say, it's rare that it occurs in any applied problem. So I don't emphasize this factoring by grouping all that much, but you should be familiar with it because you'll see examples of it when you take pre-calculus. Okay? And it's kind of neat the way it works out. So it's kind of worth doing just this silly thing. Hang on just a second. Get your question. Okay, I think just resumed itself. Okay, I just mentioned when you do factoring and you factor by grouping, there are different ways you can group this, okay? Like the 4x cubed could have been grouped with the 16x, which we did, we got somewhere, okay? So we just got a little bit of progress, but it didn't work out. Or the 4x cubed could be grouped with the negative 35, right? Well, that's even worse. It doesn't work worth a darn, but it's just something you see it as a possibility and you check it out. You pretty quickly learn that you wouldn't really try that, but you check it out until you get used to it. Okay. When you have more complicated expressions, check them out. Anyhow, this is not worth anything. Doesn't work a bit. This works a little bit. It almost kind of worked, but it didn't. Okay. Okay, good. Now, okay, just to clarify, yeah, you have 2 assignments that are due. Okay. The spring break doesn't start till next Monday. So I could have put the problem that's due the Monday we get back on Sunday, but there's no need for me to see it before Monday. There's no need for you to get it done before, a week from Monday, okay? So I gave you as much time as you might need. Now, there's one assignment that's due this week, and we're going to go over it. And then another one a little harder, the same stuff that's due. I can say officially it's due this Sunday before spring break starts. Oh, I like to give you the full spring break, but I'd get it done by Friday if you do it. Then let your brain rest. Okay, so we have, let's say we have x squared plus 5x plus 6. And we want to see if this is equal to a product of binomials. X plus some number times x plus some number. Okay? Well, I'm going to tell you what the numbers are. We didn't go over this last time, did we? So what are this pretty much detail in some class. But I don't think I went over it last time because of the alignment of the assignments. Must have been in the MDE 61 course that I did. So sometimes I've got to look, make sure I know what I've done. So this equals this. How can you verify this? Well, we've been over the distributive law to the extent that you certainly understand that this would be x times x plus 3 plus 2 times x plus 3. And that equals x squared plus 3x plus 2x plus 6. Okay? And that comes out x squared plus 5x plus 6. Now we notice, where did we get the 6? Well, we got it from the 2 and the 3. So that, and so well, 2 times 3 equals 6. That's where the 6 came from, right? Now the 2 and the 3 up here, are my 2x plus, or 3x plus 2x, right? Because we're going to have this times x, and we're going to have this times x. Okay. So that our 2 plus 3 equals 5. So that's where the 5 came from. They both came from the 2 and the 3. Because I know when I write this out that I'm going to get an x squared. All the rest depends on what numbers I choose here. Okay, well. Okay. And actually, I don't want to try that one. I want something a little more variety. I want 36 here. Now there are a lot of numbers that I can put here for this. In fact, I'm going to do 13x. I'm going to do this one for you, but then let you practice with it. Okay, so one possibility that I want to check out is, well, I could put 36 here, and I could put 1 here. That would give me 36, right? Because this times this, those are the only 2 numbers that don't have x's on them. They're going to multiply out and give me 36. Well, clearly that doesn't work because we're going to get 36x and 1x, right? That makes 37x, not 13x. So that's not so hard. I could try 36 is a perfect square. I could do x plus 6 times x plus 6, right? That would give me 36. But I have a 6x from here and a 6x from here will give me 12x. Okay? So this equals x squared plus 37x plus 36. I can do that. Okay? Here, I have x plus 6 times x plus 6. That equals x squared plus 12x plus 36. We're kind of getting close, right? That's a lot better. You have to check that one out. If it doesn't quite work, so, cross out that possibility. What's another possibility? How about x plus 2 times x plus 18? Well, I got a 2x and an 18x out of this, which is a 20x. If you use the distributive law, you should do it. That's not even close, right? Now, if we do x plus 4 times x plus 9, well, let's just go ahead and write this up. That's x times x plus 9 plus 4 times x plus 9. And that equals x squared plus 9x plus 4x plus, that's not x plus 9, it's x plus 4 here. Can't read my own handwriting. Oh, never mind. Okay. Some line. Okay. Hey, we got 36. Yeah. So, I don't know what's going on there. Okay. And that's x squared plus 13x plus 36. So that checks out, and that's my factor. Okay. I'm going to give you a couple to work on. Just write out all the possibilities until you stumble on the one that works. But then if you do that a few times, you start knowing what to look for. You can say, well, I could use 36 and 1, but shoot, that's going to give me a big number in front of x, and that's not that big, right? Same thing with the 2 and the 18. That's going to give me 20x. That's not as much too big as this one was, but still too big. Even x plus 6 times x plus 6. Now that's not enough on the x, okay? But the 4 and the 9 is a sweet spot, and that works. Now again, most trinomials, that's a trinomial, 3 terms, okay, that you run into in real life, okay? But still, it's an important thing for understanding the structure of polynomials and understanding how they work. Okay, so let's try x squared plus 7x plus 12. See how that works. Then let's try x squared minus x minus 6 and see what you can do with that. These. Okay, yeah, I'll handle that very quickly. That was good. Your possibilities here would be x plus 12 times x plus 1. And you pretty quickly say, no, that's not going to work. Then you can do x plus 2 times x plus 6. Well, that's going to give you 8x, right? So that didn't work. We're down to our last possibility, which would be x plus 3 times x plus 4. And we can write out the distributive law and say that's it. Okay? So there we have it. Let's say people got that one pretty quickly. This one's a little more, well, a little more trickier. Okay, a little more tricky. Or a little trickier. So we're going to have an x plus something and an x minus something. Okay? And there are several possibilities, actually 4 possibilities. The 6 can be factored as 1 and 6 or 2 and 3. Okay? So I'm going to work through the possibilities that don't work. Although with monic trinomials, which is your first assignment, means you have just a 1 in front of x squared. You can pretty much exhaust your possibilities. Okay, so you could have x plus 6 and x minus 1. Now, that doesn't work. We could have x plus 1 and x minus 6. Okay? And this gives you x squared plus 5x minus 6. And this gives you x squared minus 5x plus 6. Those are both fairly common factorizations that you could run into, but they don't match this one, so that doesn't work. Then we could try x plus 3 times x minus 2. And that gives you x squared plus x minus 6. So we know we're getting close if we just reverse the 2 and the 3. We get x squared minus x minus 6, and that's it. Okay? Now, we don't have time to go over examples here because we spent a lot of time on factoring monomials, and especially factoring grouping. But let's say we have 6x squared plus something minus 15. Okay. Some multiple of x. Okay. Whatever multiple of x you get here, what are your possibilities for 6x squared minus 15? That's what we have to check out. And this is, you're going to have a lot more possibilities. So I'm just going to write out possibilities here because we've only got 2 minutes left. We could have 6x plus something and x minus something, right? Where this something and this something would multiply out to 15. Or we could have 6x minus something times x plus something. Or we could have 2x plus something times 3x minus something. Or 2x minus something times 3x plus something. Okay? Now the something, this is the general form. Okay? There are 2 ways I could write out 15. I could write it as 15 times 1 or 3 times 5, right? So I could fill in my possibilities. I could do 15 here and 1 here, 15 here and 1 here, 15 here and 1 here, 15 here and 1 here. Those are all possibilities for factoring this thing, since I haven't specified what goes in front of x, right? Well, then I could have 3 and 5. So I could have 6x. The same forms that I had before, 6x plus, 6x minus, 6x minus, x plus, I said 6x, x. 2x plus, 3x minus, 2x minus, 3x plus. Then I could have 3 here. And I could have 5 here. Now that is 8 possibilities for this one. Okay. I have a number here that factors all 4 different ways, and the number here factors 5 different ways. I'll have 40 possibilities. We don't really want to write out all the possibilities, but we write out some of them to see how it works. Clearly, that's going to give us 15x and 6x. Well, it depends on what we're looking for here. Let's say what we're looking for is 27. Okay. Well, 15x and negative 6x is That's going to give me 27x, right? Got negative 15x and 6x is going to give me negative 9x. 15 times 3 is 45, but 2x times negative 1 is negative 2, that gives me 43. This gives me a negative 45 and a 40. You're going to get that number. If you do this on a few examples, you learn how to narrow things down and you learn what things might work, okay? And that's just a matter of how you look at it. Now we come down here, okay? Just real quick, it's going to be 6x squared. You have 3x and minus 6x, that's minus 27x minus 15. Okay, we kind of like that, but it's the wrong sign on the x. But if we reverse, use a negative 3 and a plus 5 in the same order, that's going to be 6x squared plus 27x minus 15, and bingo. So, one of these works. This almost works. You got to play around with the numbers, and you got to learn to play around with the numbers. So I recommend that you start by listing possibilities. Then you start to get a feel for what possibilities you shouldn't bother with. Okay. And your book will give you, and your materials will give you other ideas